Good morning, ladies and gentlemen. Thank you for joining our panel discussion today on AI. Who's leading the technology and who's influencing it? When will assisted intelligence become artificial intelligence, and who are the key technologists in this area? Will the new EU guidelines provide a structure, or will they impede development? A very good question. I'm joined by a very eminent panel. To my extreme right, we have Dave Trail from Critical Manufacturing. To his left, we have Olivier Pirou from VI Technology. To his left, we have Harold Eppinger from Co-Young. And to my right, we have Michael Ford from Aegis Corporation. So thank you very much, gentlemen, for joining us this morning. My first question, I'll get right in, is the irony is that specialists in the knowledge of machines and manufacturing processes are not the specialists that you have in AI software development, and vice versa. So how do you think these two different, disparate areas can be connected? I'll hand that one to you first, Michael, actually.
We see a huge amount of know-how in edge computing today. I mean, in the kind of machines, the great machines that we have represented here, you can now go into those machines and they're going to assist you based on analysis of data that those machines have brought out. It's amazing what can be achieved within that machine environment. But then you've got to say, well, okay, a machine in isolation can go so far. How about seeing what else can happen from information gathered from other machines in the line? So now suddenly that machine vendor is faced with the need to understand data from other paradigms within manufacturing. But then you've got the third layer on top of that, which is the factory layer. You need to understand data coming from the factory as a whole. So there are software specialists at each of these layers. And if we go to the very, very highest layer within manufacturing, which is where, for example, we want to have a fully automated factory where a customer will change their order one day and we react by making what that customer needs, and the whole factory is optimized, all of the machine vendors do what they need to do. You're talking about different kinds of people. So that kind of top level represents the opportunity for real artificial intelligence. We shouldn't call it artificial, actually, because it sounds like artificial grass. It's not real grass, is it?
But
it's kind of assisted today, but in some time it's going to be able to adapt and think, or appear to think for itself. And there are specialists who work in this area who are creating some fantastic software. But these guys don't know anything about the machines. And so the specialists on the machine side, the line area, the factory MES layer, plus these people who are looking into these technologies, we need to start to make interfaces in their knowledge and understanding so that we can start to put together a holistic picture in which there are going to be so many interoperable solutions based on a common framework of data.
Well, Harold, you experience this firsthand because you manufacture machines, obviously, and you have a lot of software programmers. So how do the two interact?
I think coming back to your question, who is triggering the results of the AI, I think this is the learning process from machine vendors. We have been capable to measure the data. We are having a clear picture about the processes, but we also realize that starting with the data analysis with AI, it's not the first choice you have to do. We utilize the AI to improve the measurement and to get more precise data out.
Right.
So less false calls, easier programming, everything is based on this to utilize a more precise data, which can be then analyzed and utilized in machine-machine communication. I think this is a very important thing. You get the point, there's a huge experience in the market. We have experts. And this expert's knowledge has to be supported by AI engines to utilize easier use of complex technology and complex production processes. Right. And I think our goal is now to build up the trust. Everybody is afraid. There are a lot of films in the market which our future is very dark. I think it's not so dark as it looks like. Yeah? But when you build up the trust that the result the machine provides you, and you would come to the same conclusion, then you can trust. And this will take a while, but I think it's important. Generating more precise data driven by AI, utilizing this data to start the communication between machine. And I agree, it's a different universe. We are coming from the inspection. We have to transfer our knowledge, our findings into the pick and place world, in the printer world, into the MS world. And this is starting really to utilize the broad communication between the different vendors.
Right. Yeah, I think you make an excellent point there on the subject of trust, because that's a critical factor in this whole smart factory journey, that to be able to get the people working in the factory on board with the smart factory journey, you really need to appoint a champion, if you like, who's familiar with the software changes that are happening and the equipment changes, and is able to take responsibility for educating and bringing everybody else on board with it. So the trust factor is quite important. Olivia, you're in the same position. You're a machine manufacturer. So what is your view on the interface between the people building the equipment and the people programming it?
Yeah, I think that the problem is always be and continue to be what to do with the data and how good is my data. And I think the trust is also coming from how good is my data, which is a combination of having the right box to measure accurately and repeatably. Actually, the data you're going to present to the outside world.
Right.
That is very important, and we shouldn't forget that the quality needs to be accurate and good to do something with it. And in Mycronic, we are really revisiting all of our product lines now with AI. I would say when we talk about AI, we'll more talk about the deep learning. We already, as Harald said, embedding some sort of machine learning algorithm to automate the programming and make each product unique, because although we could manufacture a number of products, each product is very unique, and machine learning is assisting the programmer in coping with this unicity of the product. Okay,
Yeah.
So that's one thing. But then most of our deep learning experts that are now working for the last years in San Jose in the Center for Deep Learning that Mycronic opened, really realized the potential of, with good data, going from the step of information and accurate information to the process.
Yeah.
And this is becoming a reality. I think it's now, we are well on our way, but from what we see, we believe that within 5 to 10 years maximum, we will achieve the zero defect plant with minimum human assistance. And I think when you look at, just as an example, Google introduced in 2017 the AlphaGo that beat the world champion for the Go game. And you realize that the number of probability for chess would be probably 10 following by 47 zeros probability.
Yep.
For the AlphaGo is 10 following by 170 zeros.
Right.
And that has been 2017. We thought it would take 20 years to go there.
Yep.
And so we shouldn't underestimate that also now the barriers to entry with AI engines are getting lower and lower. And this is a technology that is that will be within our hands, with all our hands now. And I think the trust will be there in the coming years.
Okay. So, Dave, you're in the software business. We make a good point there about getting the quality of the data right. One of the most common terms I've heard this week around the show is everybody's talking about raw data. Got to get it. If you get raw data, it's clean, it's good, and you can work with that, and then you can build that into libraries, basically, at the moment. What is your approach to it?
When we start talking about data and data collection and artificial intelligence, which is what we're talking about today, I think one of the hindrances that we've had over the years is access to the data and the cleanliness of the data and the availability of certain types of data across different types of machines. I think the technology has evolved to a sense now that most active equipment on the factory floor now provides a decent set of data that's pretty accurate, being able to take in that data and utilize it in a format that benefits the customers or benefits the project is, not only key, it's a requirement. As we start talking about artificial intelligence and who's going to, be leading that field, I think it's really going to take a different type of person than what a lot of companies currently have within their organizations. This person has to not only be technical, but they have to be versed in change management, as well as, in business principles as well. This can't be held entirely in a computer science office somewhere in some building. They need to understand the reality of how artificial intelligence may benefit the organization. The other thing that we have to be a little bit careful about is when we're talking about artificial intelligence, I think in a lot of ways we still have a technology looking for a problem as opposed to a problem looking for a technology. Mm-hmm. And I think as we evolve as an industry, I think those problems looking for a solution are starting to present themselves. And a lot of that revolves around the ROI that's generated when you start using these types of technologies. And that's why things like maintenance and predictive maintenance and things like that is really the first areas where artificial intelligence is going to start to flourish, because that's initially where the highest ROI in this type of technology is going to be utilized.
Right, so that's sort of tracking motors and bearings in machines, knowing when their design life is about to come to an end, and getting the maintenance in there beforehand so that you maintain the uptime of the equipment.
Exactly, but to be able to get to that area where you're making those predictions, you need a tremendous amount of data points to be able to make those types of leaps.
Right.
And it's just recently, over the past few years or so, that the amount of data that we're able to get off of the factory floor is coming close to the amount of data necessary to be able to make those types of decisions, whether they're through human written algorithms or actual artificial intelligence.
Right.
I'd just like to add, actually there's no such thing here in this case as a solution looking for a problem. All of this predictive maintenance, the lean materials. I installed my first lean material system back in the 1990s. Predictive maintenance was happening at that point. There are problems that are well established. There are opportunities in manufacturing to utilize data that are very, very well established. What has changed is the fact that this data is now being gathered by the intelligent machines and being communicated in a way that makes solutions interoperable across the whole factory.
And there's so much of it.
So the problem has finally found a solution that works rather than the other way around, in my opinion.
Yeah, and I think the mere fact there's so much of it, and being able to interpret that data quickly, and to turn it into something that's usable, actionable data, is really where a lot of the bottlenecks are. Yes?
Yes, and I think this is at least to me, the first productronica when I really feel the push for customers. Mm-hmm. And customers coming to us with full hard drives of data, and they say, okay, I'm collecting this data since now 2013, and these are my defects and false codes, and this is how I label my data, and what can you do with it? Now, we tried in our own office to have a small engine of this small topology and problem, but we really feel that there's a push, and as I said, the barriers to entry maybe are not so high that we can actually do something for them.
Right.
Yeah.
I would like to catch up this topic with this is my hard drive with defect and false codes. And for my opinion, this is exactly the wrong approach. It's happened and you cannot learn from this. It's much more important, and I think it starts with process visualization. It starts to understand the process much more and quicker than it was in the past. It doesn't make sense to read a book like this and analyzing day by day the data. No, you have to be guided to the spot. And then you have to be advised what to do. And a good example is the communication in the moment we realized between pick and place machines, where we really dedicate nozzle 4, header 3, and machine calibrating. So it's already in the execution to reduce the maintenance time, to predict the maintenance, but also to identify the root cause of a problem, which takes a human days. Yep. Or spending the whole day in front of the line waiting that a simple random defect happened. And I think this is the goal.
I think you're both right. because certainly there is huge value in that. But I chair the IPC's Committee for Traceability, and people think about traceability as being, oh, we're gathering huge amounts of data just in case. No, the actual use of data is to understand from the past what worked and what didn't. You could make 1,000 products, and 999 are absolutely perfect. There's one which is a defect. What was the cause of that defect? Surely, if it was simple, then we would have noticed it. But through the analysis of all of the different data points that we've got, all of that data on that hard drive, you can find out the unique set of circumstances that contributed to make that defect, so that you know how that was caused, and you can be sure the other 999 can be shipped. So that's a very, very valuable piece of information. That's we've been doing for quite a long time based on information from machines. So there is two layers of solution here, and this is what I was saying at the beginning. You have the layer that works very effectively from this historical data, and then you have the real-time layer that acts to prevent defects. So when you buy a Co-Young machine, you don't buy that anymore to filter quality. That's the old school way of thinking. Co-Young machines avoid defects in the first place by the analysis of data of ongoing optimizations.
Right.
So it's a whole different layer and a whole new generation of solutions that have never been available before. And it changes the way the industry works.
But that's through using deep learning and storing that data so that if these defects occur, it can access that from the library, basically, going across.
But there are no more defects. I mean, you said the goal is 0 defects, and this is what we're after.
Exactly. The goal is 0 defects that we would like to. And we watched this dream since 20 years or longer. But there's still a hope that we get to the 0 defects.
It's not a hope. We're going to get there. I mean, your targets are great.
No, maybe we'll retire before.
Maybe so.
The old stake also is to is how to remove the noise in the data, and whatever process we have, we know we operate within control limits. I mean, be it a printer, pick and place, inspection machine, whatever is measuring. I mean, as long as you measure, you have.
Well, that's one of the reasons
limit.
everybody's talking about raw data now. They want to clean out a lot of the noise that's in there.
So removing machine noise, removing human noise, because there are also some of the plant that in which we operate, their top quality problem is misclassification by an operator.
Right.
The machine measured well and told the truth, and it was disqualified by the operator. And this is the kind of problems that our customers don't want to see anymore. Huh?
But just to bring it back to the next layer for Dave and I, because it's about adding the context. So it's all about removing the noise, but we have to add context. We have to bring sanity to that data, because machines work in isolation. We need to understand as a factory level, how are we going to use those bits of data to create the model for optimization, and understanding how to make better quality and planning of the factory. So we have another distinct layer there.
Right. Okay.
Absolutely.
So, I mean, all of these examples you've just given us are really what I would call assisted intelligence. They're not artificial intelligence. I mean, artificial intelligence is when the machine makes a decision without
Specific programming.
So we're really at the stage of assisted intelligence at the moment. There are EU guidelines out there for artificial intelligence, which are quite striking, actually. It's interesting to see that one of the things they require is that even in the case of artificial intelligence, it needs to be traced back to somebody, a human, to be able to make a final decision in the event of a query. Do you think that's going to really assist the manufacturing, or do you think that's going to be a hindrance?
I think it's interesting that we're already writing regulations on things that are just, in their infancy, they're almost non-existent. As you mentioned before, I mean, most of the quote-unquote artificial intelligence that we're talking about now is really human-written algorithms, processing data, which is in essence a calculator of sorts. So, true artificial intelligence, where those algorithms are being calculated, artificially, as opposed to written by some computer science person, that is starting to occur in some of the machine learning applications and things like that. But the attempt to put guidelines and restrictions on things before they've even really gotten out of the gate, I think it's sad in some ways, I guess, because you do need to control things, and you do need to protect the human operator. You need to be able to protect the human beings in the factory, but also you need to allow technology to be able to evolve on its own. Also, one of the things that I've heard recently is the Stone Age didn't end because they ran out of stones. The Stone Age ended because there was a new technology that was better and served the purpose much better. So I think we need to be able to have the flexibility to allow technologies to evolve and thrive before prohibitive restrictions are put upon them.
Right, okay.
The way that software is developed is, we know it very well, all of us here, but it's not as clever as you think. Sometimes there are just billions and trillions of calculations going on, which are measuring things and assessing things, coming up with like a score of how well something is working. That score is dependent on a set of rules that measure what is the outcome, how effective is the outcome. What do I want to see? Do I want to see higher productivity? Do I want to see higher throughput, better asset utilization, better quality, delivery on time? How important is each one of those things? And we assign a kind of priority or an importance against those kind of criteria. And this is an algorithm which then is written specifically into code. And if it makes a decision based on that criteria, then okay, the fault, if there is a fault to be found, would be then with the coder to say, well, you got that rule incorrectly. It's not right. It's not achieving the result. With true artificial intelligence, we have the added ability for the intelligence itself to change its own goals. So it will measure things in a different way over a longer period, perhaps including more information like performance of something in the market or availability of materials in the market. So it's looking at things, assessing its own measurement for the outcome and changing those parameters. So no programmer ever programmed those parameters. So if something were to happen, who is going to take the responsibility according to these EU guidelines?
I know.
Is it the person who set up that thing in motion in the first place but didn't see or foresee the consequences of it? Or is it the artificial intelligence itself? It's something that science fiction writers have been writing about for a very long time. For the next 1, 2, 5, 10 years, we've probably not really got to worry about it, and we wouldn't want to stifle the creation of that software. But there will come a point where we do need to be thinking, what are the goals that we want our software AIs to achieve?
Yeah, very well said. So we're running, unfortunately, starting to run out of time. So I want to give the last 2 words to both the machine vendors that are on the stage here. We'll start off with Olivier, and then we'll finish with Harold.
I think just to bounce back on the maturity of technologies, what you're reflecting on. I mean, this is what we see today, and we try to solve the problem. Is identifying the problem is the first place. To say, okay, is artificial intelligence is able to solve this problem, or it will be a rule-based kind of algorithm that will solve the problem? And we see this competition, like a competition between humanized machine and augmenting humans. But this is the technology that we also put in kind of concurrent engineering to try to solve the most efficiently the problem. And I agree with you. For the moment, the maturity is yet to be proven on the large scale.
Okay, Harold, last word to you. You've got an AI facility down in San Diego, I think it is, working on this stuff all the time.
Yes.
So
we put an extra R&D center for this because we saw already 4 years ago that this will be master influencer in the performance of the machine and utilizing the data. I would like to come back to the utilization. When the 3D becomes accepted in the market, it was the first time that it starts that the data became trustful. The data we share with MES system, the data we share with machine vendors have been not question mark before. Before, all the time, there was the issue of the false codes or the programming. Who did the programming? Today, we reach a different level. The data is trustful, should be trustful. But much more, we will utilize this data to support the operators, the process managers, the line managers, the factory, and we prove with this, and don't underestimate this, we prove the quality towards the end customer. He can rely on, because the first time he can look at the data and he has a digital twin. And he can see even the 24/7 performance, not just during a 1-hour audit. We have some more things. This kind of supporting decision processes,
Right.
supporting critical findings. As I mentioned before, it doesn't make sense to stand in front of the machine. The obvious things is catched in 5 seconds. Go there, press the button, done. But if it's not so obvious, it starts to burn money, it starts to bother people, and you increase the pressure. Why you don't find it? This is the root cause, this is the way. And this will be a phase for the next 2 to 5 years to gain the trust, to learn from the humans how they decide, and then applying this as a independent, self-learning, AI-driven, total solution which really can assist the future factory and, let me say, secure the competitiveness
Yeah.
in the world.
Yeah. Fascinating subject, gentlemen. I wish we had more time to talk about it, but unfortunately we don't. So I'm going to have to say a very big thank you to Dave Trail from Critical
Thanks,
Manufacturing, Olivia Peru from VI Technology, Harold Eppinger from Young, and of course Michael Ford from Aegis Corporation.
Thank you.
Okay, and
Thank
thank
you
you
for
for
having
joining
us.
us today. Thank you.